Okay. See, in the previous class, if you remember, we have discussed about we have discussed about uh, two problems. If you remember, we have stopped here, right? We have stopped here, that find out the net ultimate, net safe, gross safe bearing capacity. I have also given this similar problem in your quiz last week. Okay, so hopefully you have solved it. Now in today's class we'll discuss little bit more theoretical things, and then in again tomorrow's class again we'll discuss some more numerical problems. So in the today's class we'll discuss about shallow foundation, and if you remember, I was talking about the effect of eccentricity on load bearing capacity or the bearing capacity of shallow foundation. That is the point we will be discussing first today. So you see, if you see Terzaghis bearing capacity equation, that CNC, that Q ultimate is equal to CNC gamma d NQ plus 0.5 gamma b n gamma. In that equation, you see, till now we have discussed about introduction of one factor by Terzaghi, that is called shape factor. And if you have seen that shape factor is always 1, that is SC, SQ and S gamma values are always 1 for strip footing, as Terzaghi has developed his bearing capacity equation assuming the footing to be a strip footing, and it is a shallow foundation, and the footing or the soil is necessarily failing by general shear failure. So how to modify the general shear failure equation into a local shear failure equation? We have understood it through Terzaghi's modification of the formula, where Terzaghi has mentioned, if you want to change the general shear failure ultimate bearing capacity to local shear failure ultimate bearing capacity, then you just make that cohesion value as 2/3 of the original cohesion, and the shear strength or the not shear strength, the angle of internal friction, that is the phi value, you just take as tan phi m is equal to 2/3 of tan phi. So basically he has spoken about a mobilized shear coefficients of soil for cohesion and angle of internal friction. After that, you have seen that shape factors effect are also being taken into consideration in the equation. As well, we have seen what is the effect of water table on the bearing capacity using the two factors called RW1 and RW2. In the previous classes, we have discussed the problems about those concepts of how the bearing capacity will be getting affected because of the water table effect, because of the shape factor effect, and because of the angle of internal friction or local shear failure effect. We haven't taken a problem for local shear failure effect. We will be discussing it in later classes. Okay. Now today we will be discussing the effect of eccentricity. That means when the load on the foundation is not put concentrically. Concentrically means when the load is not acting exactly at the centroid of the footing. If the load is not acting at the centroid of the footing, then such kind of load will be called as eccentric loading. So whenever there is an eccentric loading happening onto a footing, the bearing capacity of the footing will change, and how that effect of eccentricity will be taken into the bearing capacity equation, we will discuss it today. So the method which will be applied for reducing the bearing capacity, why should I say, why I am saying that reducing the bearing capacity, because effectively what the eccentricity is going to do, the effective breadth and effective length of the footing will be actually getting reduced because of eccentricity. So, see the effective area method, you can see in the slide that effective area method. See what is being done in this method. In this method you can observe the length and breadth of the footing. So, whatever is the exact length and whatever is the exact breadth of the footing, that will be reduced to take care about the effect of eccentricity. So, footing length and breadth will be reduced by the amount of eccentricity, and how much amount of eccentricity and how much amount of subtraction you will have to do, that is being specified by some other soil mechanics as well as in the Indian Standard Code IS 6403 it is specified. So, when you want to take into effect of the eccentricity, then what you will do, you reduce the length and breadth of the footing, and then what you do, then the area of the footing, whatever area you are considering for the footing, it needs to be calculated using the reduced length. This is very important, the reduced length and reduced breadth of the footing. So, whenever there is an effect of eccentricity, first you will have to do what? You will have to change the effective length and effective breadth of the footing. So, find out the effective length and effective breadth of the footing. You will have to subtract the amount of eccentricity, and what amount of eccentricity you will have to subtract, that we will discuss in today's class. Okay? And use those modified values, that means those effective length and effective breadth actually you use for calculation of the bearing capacity value. Now, see why the eccentricity will come into a footing. So, eccentricity you can observe that primarily it may be occurring because of the two reasons. You see there are two cases I have mentioned here, case 1 and case 2. So, you see case 1, the first case you notice, when the vertical load is not acting through the centroid of the section of the footing. This is the primary reason. You see, this is the primary reason. See, there is a footing of 1 by 1 meter footing, and at the centroid level, so the footing centroid will be just at 0.5 meter and 0.5 meter, right, 1 by 1 footing. So, 0.5 meter from both sides if you come. So, exactly at that level if the footing is placed, column is placed, then the footing will be concentrically placed. However, if the footing instead of, see, if this footing is somewhere here at this position, then it will be concentrically placed. But you see in the case 1 what is happening, the vertical load which is coming from the column to the footing, it is not acting at the centroid of the footing. So, you see, if it would have been at the centroid of the footing, maybe you see if the load was at centroid of the footing, it would have been somewhere here, but instead of that you see the column is placed over here. So, you see this is the amount of eccentricity you are introducing into a footing. This is the amount of eccentricity from here to here. So, from the centroid level, what is the by the amount that footing is shifted, the column is shifted, and the vertical load, the action point of action of the vertical load is being shifted by that amount will be considered as eccentricity. So, this is the case number 1. This is a very common kind of case. And the second case, you see, when the vertical load is acting through the centroid. See, in this case you notice the vertical load is acting through the centroid. However, you notice there is a moment acting on the column or the column base. So, see, there is a moment coming into picture. So, because of the introduction of the moment, there will be some effect of eccentricity will be coming into the footing. So, basically whenever there will be a moment acting on a column, so that column will be trying to overturn the footing, and thus that moment will be taken care in the bearing capacity equation through the effect of eccentricity. So, how does this moment will come? See, it is very simple to understand. See, the moment will come because of this. Let's say there is a vertical load acting like this on this footing. There is a vertical load is acting on this. So, there is no moment in that case. However, you see, if there is a horizontal load acting on this, so what will happen? If there is an horizontal load acting like this on this footing, so what it will do? This horizontal load up to this distance, if you multiply this horizontal load and this lever arm, so if you just take this distance from here to here, so what it will do? It will create a moment about the base of the footing, and this moment you need to take care using the effect of eccentricity. You are getting? So, considering this effect of eccentricity, what exactly you will have to do? You will have to reduce the length and breadth of the footing, and after reduction of the length and breadth, you will be getting the effective length and effective breadth of the footing, and considering the effective length and effective breadth, you go on computing the value of bearing capacity. And whatever it may be, you have understood at this point that first you will have to calculate the ultimate bearing capacity. So, in the ultimate bearing capacity, if those effects are being considered, after that all other values will be taking care about those effects. Okay? All other values means ultimate bearing capacity, then net ultimate bearing capacity, then safe bearing capacity, net safe bearing capacity, all those values will be taken care about the effect of eccentricity. Okay? Now you see, so what is actually being done here? You see, this is actually the length of the footing. Let's say from here to here, I'll just show you. See, let's say from here to here, this is the breadth of the footing, and from here to here, the original length of the footing. Correct? So, original length of the footing. So, this is actually your B, this is actually your breadth of the footing, and this is actually your length of the footing. So, this is B, this is L. Now, you see, you are placing a column, here. So, see, because of this L and B, see, the centroid of the footing will be going somewhere here, centroid of the footing will be remaining at this point. This here is the point where the centroid will be there. So, this is the point where is the centroid will be, right. So, you see, in this case, if this footing would have been at this position, then you will be going with this breadth B and this length L. However, you see, in this case, this column is not placed over here. You see, the column is not placed over here. It is not placed at the centroid of the footing. Rather, what is being done, the column is little bit shifted. So, this is the case actually. This is the case. So, this is the front view, and from the top view, if you see, this column is when little bit shifted. You see, this is the top view, and you are seeing that on the footing, this column is coming to this position. Have you noticed? So, when this column is being coming to this position, at that time what is happening? At that time, you see, you are shifting the centroid of the column, which is basically this one. You are shifting the centroid of the column from the centroid of the footing by an amount Ex. So, this is the x directional eccentricity. So, whatever is the breadth direction, along that we will be considering the footing eccentricity as eccentricity in the x direction. Whenever we will be considering the length direction, along that we will be considering the eccentricity in the y direction, and we will be considering the value of eccentricity as Ey. So, you see, in this case, this footing is being placed at an eccentricity of Ex from here on the x direction along the width direction, and along the length direction it is placed at eccentricity of Ui. Now, what does the experimental values and other observation says, as well as what is Indian Standard Code says, that because of this eccentrically placing of the footing, the length of the breadth of the footing will be reduced and the effective breadth will be b dash. So, see this b from here to here, whatever is b, that b will not remain, instead it will become b dash. So, instead it will just become b dash. So, from here to here it is actually b dash. So, by how much amount this reduction will happen? So, the amount of reduction will be the breadth of the footing. So, whatever is the breadth of the footing minus this distance, and this distance is being observed as it will be twice into Ex. So, Ex, you notice it is the eccentricity in the x direction. So, twice Ex if you subtract from B, then you are going to get the effective width of the footing. Okay. Exactly in the similar way, if you notice, the effective length of the footing will be also reduced, you see. So, length was this one, now this effective length will be reduced to this one. So, you see this much portion of the footing, this shaded portion of the footing ideally will not be participating into any way in the bearing capacity increase. Okay. So, the load carrying capacity ideally will be getting reduced because of the eccentricity, because you see the length and breadth, or both the effective length and effective breadth of the footing is getting reduced by an amount twice Ex in the breadth direction and twice Ey in the length direction. So, the effective area of the footing, thus it will become b dash into L dash. Now, in the bearing capacity, yes
सर बोल रहे हैं कि सर तो 2 टाइम्स क्यों मल्टीप्लाई कर रहे हैं, 2 टाइम्स इसेंट्रिसिटी को 2 into Ex.
Yes, 2 times. Why it is 2 times? Why it is 2 times? Okay, basically you see this direction it is this direction it is being shifted by E. Okay, Ex. Okay, this direction it is shifted by Ey. Okay. Now, if you only subtract this by E, if it is only subtracted by E, then this distance, whatever is this distance will not be covered, because see when you are here, you see it is balanced on this side as well as this side. So, if you are putting an eccentricity in the x direction by an amount Ex, so to balance on both sides, because what you are actually doing, you need to shift the centroid of this column, and you will have to put the centroid at a perfect position. That means this b dash and L dash will be having the centroid, the centroid of the b dash and L dash should be coinciding with the centroid of this footing, and if you mathematically calculate it, then to get that you will have to subtract twice amount of Ex. Otherwise, if you only subtract Ex, you see if you only subtract Ex, this centroid and this centroid will not be matching with this column centroid. Okay. So, it will not be only one Ex, it will be twice Ex, and I will show you Indian Standard Code also will tell it about tell this value as twice Ex. It cannot be subtracted only Ex. Okay. Is it clear? See, in this case it is B, in this case it is L. So, the centroid is somewhere here. Now, you are shifting the column to some position. So, the changed length and breadth of the footing should be such that the centroid of that effective length and effective breadth footing should be coinciding with the centroid of this column, and to get the effect of that, you need to subtract the amount of twice of the eccentricity to get that effective width and get the effective length. Okay. Is there any more doubt?
Yes, sir.
Okay.
Yes, sir.
See, basically if you
Hello.
mathematically if you see, you will have to go and calculate the centroid of the footing in that case. Okay, so if you calculate the centroid and position of the footing, you are going to get these values. Okay, so you need not to worry about it. This, if you mathematically calculate it, you are going to get this twice Ex value. So Indian Standard Code also says about twice Ex. Okay, so you subtract twice Ex. Okay.
Yes, sir.
Okay, next is you see this, how do you calculate in this case? See, when there is a moment coming, I have shown you how the moment will come. How the moment will come? The moment will come because of some horizontal load acting, because at this. So if the horizontal load is acting at this level, so if you multiply this horizontal load with this distance from here to here, you are going to get a moment, right? You are going to get a moment. Now this moment, because of this moment, how will you take care about the effect of eccentricity for this moment? So you see, I have shown here. So you see, FHX and DFH. DFH means actually what I am trying to say, the moments can be also in two direction. It can be in mx, it can be in my, because you see, when this is the diagram you are seeing in 2-dimension space. However, if you think about a 3-dimension space, then you see this load may be acting from this side, or this may be coming from a perpendicular direction from the other, right? So when this load will be acting in the x direction, it will be creating a moment. When the load will be coming from the y direction, it will be creating moment in some other direction. So how the moment will be calculated? Moment will be calculated using this load multiplied by this distance. And what is this distance? Distance is nothing but this the load, the horizontal load, wherever it is acting, this load multiplied by the distance from the load to the base of the footing. And this is what I have shown here. This FHX means the horizontal load in the x direction multiplied by DFH means distance of the horizontal load from up to the base of the footing. Exactly, for calculation of the moment in the y direction, it will be horizontal force acting in the y direction multiplied by DFH. And DFH, you see, DFH is nothing but this one, this arrow, whatever I am showing, this is actually your DFH, and this arrow, whatever I am showing, this is actually your sorry, this is actually your FHX or FHY. Now once you have calculated this moment, then how do you get the eccentricity Ex and eccentricity Ey from these moments? So it's very simple. You remember this, that in case of moment loading, what you have to do, eccentricity Ex can be calculated as moment in the x direction or moment in the y direction divided by the vertical load. Okay, so eccentricity in the x direction can be calculated just by dividing the moment in the x direction by the vertical load. And what is the vertical load? Vertical load is nothing but this arrow. So this vertical load, whatever will be acting, so this is actually your FV. So this is the vertical load which is acting over here. So this vertical load actually you will have to divide, the moment needs to be divided with this vertical load to get the value of eccentricity. So actually you are getting that effect of moment needs to be taken care in the bearing capacity equation by through the effect of eccentricity. This point you should be very clear about. Okay, so eccentricity effect on bearing capacity is actually, if you understand, that it will reduce the amount of bearing capacity. Okay, because of the eccentricity, the effective width and effective breadth of the footing will be reducing. And if you see the bearing capacity equation of Terzaghi also, that QU is equal to CNC plus gamma D NQ, see those two things will be remaining unchanged, but the third term, if you see, that says 0.5 gamma B n gamma, and in that case your B will become, because of the effect of its eccentricity, your B needs to be replaced with B dash. It will not be B in that case, please remember, it needs to be replaced with B dash. See, you need not go back and put any value of eccentricity in the bearing capacity equation. Instead, what you are doing, you are actually reducing the amount of length and breadth of the footing. So, when you have reduced the breadth of the footing, you see you are putting the modified breadth of the footing, that is the effective breadth of the footing, in the bearing capacity equation. However, you also remember that Terzaghi's equation is for the strip footing, and if the footing is stripped, then CNC gamma dnq 0.5 gamma b n gamma, in that equation you just put B dash instead of B, the effect of eccentricity will be taken care. But if you think about a rectangular footing, a square footing, or a circular footing, then you see in the equation of the shape factors the length is also introduced, right. So, to take care about a rectangular footing's eccentricity effect into bearing capacity, you will have to use the changed length or the effective length, which is nothing but L dash equal L dash, which is equal to L minus twice Ui. So, that L dash you need to use in that equation. So, what I mean to say, I will just go back to one slide, this one. See, this one, when you will be using the shape factor values, see in the shape factor values for rectangular footing, you see B is there and L is there. In this case D is there, L is there. So, in this value, what you should do, instead of B you need to use B dash, instead of L you need to use L dash if there is an eccentricity happening on the footing, or if the load from the column is acting eccentrically on the footing. And we have understood that the effect of eccentricity primarily may come because of two cases. One is because of the placing of the column at an eccentric level, placing of the column not at the centroid, instead of the centroid this is little bit shifted, or because of some moment acting on the column. Through that moment, that column will be also creating some moment at the base of the footing, and that primarily will come because of the horizontal load whichever will be acting on the column. And from that moment, whatever you will be calculating in the x direction and y direction, if you just divide that moment in x direction and y direction by the vertical load whatever is acting on the column, you are going to get the value of eccentricity. Once you get the value of eccentricity, you just subtract twice the value of eccentricity from the breadth and the width, breadth and the length of the column to get the effective breadth and effective length of the column. Once you get the effective breadth and effective length of the column, footing, you use those values in the bearing capacity equation to calculate the final bearing capacity, which will automatically take care about the effect of eccentricity on the footing. Okay, is there any doubt?
Yes, sir.
Is there doubt?
Sir, why we use shape factor, sir?
Why we use shape factor? See,
yes, sir.
You are not clear about shape factor. Have you attended previous classes?
No, sir. Due to some network issue, I am not attended the previous classes, sir.
Who is this?
Amit Kumar, sir.
Amit Kumar. Okay. See the shape factor effect. See, please go through the slide. Okay. Just I will tell 1 minute about this. See, Terzaghi's bearing capacity equation. Terzaghi's bearing capacity equation is valid for strip footing and it is valid for general shear failure. So, if you want to apply this bearing capacity equation CNC gamma d NQ and gamma b n gamma for any other kind of footing other than this strip footing, then you will have to multiply these individual values with a factor to take into the effect of shape of the footing, and that is actually shape factor, and that is being defined by Terzaghi, okay, for Terzaghi's bearing capacity equation. So, you notice in case of strip footing the values of shape factors are 1 1 1. In case of square footing they are different, in case of circular footing they are different, in case of rectangular footing they are different. So, basically Terzaghi's shape factor is a factor which will take care about the shape of the footing in the ultimate bearing capacity equation, which is derived by Terzaghi for strip footing. So, to convert the bearing capacity equation of strip footing into some other footings like square footing, circular footing, rectangular footing, you will have to use a factor, and that factor is called shape factor. Okay.
Okay, sir.
Okay, let us proceed. Okay, now gradually we have understood, you see, about Terzaghi's equation and all other things related to bearing capacity and what is the effect of bearing capacity on Terzaghi's equation, different things like shape of the footing. Then we have seen what is the effect of eccentricity of footing. Then we have seen what is the effect of angle of internal resistance of the soil. That means because of the angle of internal resistance of soil, some soil will be failing by general shear failure, some soil will be failing by local shear failure. So, what is the effect of general shear failure and local shear failure in the bearing capacity equation, that we have observed. Then we have understood what is the effect of water table on the bearing capacity, and we have solved one problem also on that. Now, today after this discussion on Terzaghi's equation, we will be moving to our Indian Standard Code. So, briefly today we will discuss about our Indian Standard Code. Okay. Now, let us see. See, Indian Standard Code, that is IS 6403/1981. So, I have shared this code with you, right? All of you have the code?
Yes, sir.
Yes. So, please go through the code, okay? Please go through the code. I will explain the code, okay, but you will have to go through the code, otherwise you will not understand it very clearly, okay. So, see, Indian Standard Code IS 6403/1981, you say in this code, this is the code for bearing capacity. So, what this Indian Standard Code says, can you see this? Can you see this PDF document?
Yes, sir.
Yes.
Yes, sir.
Yes,
So,
sir.
this is Indian Standard Code 6403/1981. This has been reaffirmed. Reaffirmed means there with some modifications. This is been affirmed that whatever recommendations are being given in this code, they are perfect. In 1997, this again reaffirmed, and this is the 6th reprint. You may have any other reprint also if you download it from the internet, okay, but I have this version. So, you see, Indian Standard Code, what is 6403, IS 6403? It is nothing but the Indian Standard Code of practice for determination of bearing capacity of shallow foundation, and that is what we are discussing, right? We are discussing about determination of shallow foundation, determination of bearing capacity for shallow foundation. Now, you see, in this code, first few pages always there are some details is given, then you see there are some forwards written, this, and you see these terminologies are defined. Whatever terminologies you see this net loading intensity, ultimate bearing capacity, safe bearing capacity, safe bearing pressure, allowable bearing capacity. If you remember, we have discussed these terms earlier. So, if you remember I have told you that these terms are very important. You remember these terms? All these terms we have discussed: gross pressure, net pressure, ultimate bearing capacity, net ultimate, net safe, gross safe bearing pressure, and then allowable bearing pressure. So these terms are being discussed over here. These are similar terms whatever we have discussed, and then there are some general terms discussed, that is relative density, then effective surcharge, then footing, foundation. All these terms we have already discussed, and then it gives the details about these symbols. Okay, so these symbols we will take up when we will be discussing about our formula for bearing capacity at a detail level, because if we try to understand these symbols here, you will be getting confused. Okay, so going after this, you see ultimate bearing capacity. So the code specifies about ultimate bearing capacity, and see in the presentation I have given you, I tried to give you some page numbers also. See, refer clause 5.1.1 page number 7. So if you refer to this code, this is the 5 ultimate net bearing capacity. You see, please see here, net ultimate bearing capacity. It is talking about net ultimate bearing capacity, and this net ultimate bearing capacity, as per the code, if you see, it is given in this clause. This I'll talk about this later. Okay, we have just now discussed L dash equal to L minus twice L, B dash equal to B minus twice B. Okay, we'll come to that later. So see, the soil with cohesion and angle of shearing resistance, that's what we are discussing for Terzaghi's bearing capacity also. That is for a C5 soil, what is the ultimate bearing capacity, right? And you see, this is what the code says. You see, the code is not saying about ultimate bearing capacity. Instead, you notice it is saying about ultimate net bearing capacity. That means code is talking about net ultimate bearing capacity. Are you getting? Code is speaking about net ultimate bearing capacity, and that's why this formula is taking this form. Now let us see what is this formula. We have already understood this in our bearing capacity equation. Okay, so you see, I'll take this in the previous problem, whatever we have discussed, from that only again I'll take that formula and just show you. So you see, what is Terzaghi's bearing capacity formula? Terzaghi has said this one, right? Gamma B N gamma. So what is Terzaghi? Terzaghi is Q ultimate equal to CNC gamma D NQ plus 0.5 gamma B N gamma, right? So this is your Q ultimate. This is your ultimate bearing capacity. And what is net ultimate bearing capacity? Can anyone tell me what is Q net ultimate? If I write Q NU, bolo, what is net ultimate bearing capacity? Anyone?
Sir, ultimate bearing capacity minus the gamma D.
Yes. So ultimate bearing capacity minus gamma D. So this is my ultimate bearing capacity, right? And after that I will subtract gamma. I am just writing gamma. Okay, gamma into D. Okay. Now what is the value of ultimate bearing capacity? What is the value of ultimate bearing capacity? Ultimate bearing capacity is nothing but this one, CNC gamma D NQ plus 0.5 gamma B N gamma. That is what is Terzaghi, right? So what is being done? Ultimate bearing capacity is nothing but this one. Okay. So if I do this and simplify this, you see what I am going to get. So you see, there is gamma D term here, there is gamma D term here. Can you notice? So what this equation will change to? So you see, this equation in a simplified form, I can write it in this way. You see what I can write it? I can write CNC, I take gamma D common, and if I take gamma D common, what will become? NQ, and this gamma D if I take out, then it will become NQ minus 1, correct? And then it will be 0.5 gamma B N gamma, and gamma D I have taken common, so it will go from here. Have you understood this? Tell me what I have done. Is it clear or not?
Yes, sir, it is clear.
Clear, okay. So you see, QNU is equal to CNC gamma D NQ minus 1 0.5 gamma B N gamma. Okay, and what is this QNU? QNU is nothing but the net ultimate bearing capacity, and that's what is code is also saying. You see, the code is saying the net ultimate bearing capacity, ultimate net bearing capacity, and ultimate net bearing capacity. When the code is saying, you see, the code is writing it as QD. So whatever we have written as QU, code is writing as QD, and code is saying CNC plus Q. Code has written this as Q. So what is Q? Q is nothing but, you see what we have said, gamma D is what? Gamma D is what? Gamma D is nothing but Q. Because what is gamma D? Gamma D is nothing but Q. Q is what? Q is the surcharge. So Q is equal to gamma into D, which is nothing but surcharge. Okay, or we can say overburden. Okay, so this surcharge weight or this overburden weight is replaced by Q. So you see, this is the form code has adopted. So there is nothing to get confused about this formula. Have you got it? So you see, in case of general shear failure, exactly whatever Terzaghi has said, Indian Standard Code is also saying that. You notice? Is it clear? So whatever Terzaghi has said, Indian Standard Code is also saying the same thing, if you notice. Okay, and you see, for the local shear failure, what the code is saying? The code is saying what Terzaghi has said for the local shear failure. You see, you remember? So for local shear failure, this will become 2 by 3, correct? So obviously this will also become 2 by 3. Okay, because when the shear failure is happening because of local shear, then you will have to use 2/3 of the cohesion of the original cohesion. So it will become 2/3 C. Now what will happen to this gamma D, NQ and other things? So you remember what will happen? So you see, because of the change in phi, if you remember what I have said, that tan of phi m, so tan of phi m, that is mobilized, tan of phi mobilized phi mobilized will be equal to how much? Bolo? 2/3 of tan of phi. You remember this? This is actually your general shear and local shear difference. So if you go back again to the slide and see, then you will be clear. See, come to this slide. Have we discussed this? See, in case of local shear failure, what you have said, you need to mobilize it, right? So you need to reduce your C by 2/3 amount, and phi needs to be reduced in this way, that tan phi m you need to calculate is equal to 2/3 of tan phi. So your phi m is going to be equal to tan inverse of 2/3 of tan phi, right? So once you get the value of phi m corresponding to that phi m, which will be lesser than this phi, okay? So corresponding to that phi m, you will have to get the value of NC, NQ and N gamma, and thus when you will be considering this concept, see, this NC will be coming with a dash value. What is dash? Because you see, these dashes will come on these three factors, because whatever value of NC, NQ, N gamma you used to have for a particular phi, because of the effect of local shear failure, as the phi will be getting reduced, the value of NC, NQ and N gamma will be also changing, because the phi will be directly dependent, the NC, NQ, N gamma factors will be directly dependent on phi. So, when there is a reduction of phi, there will be reduction in the value of NC, NQ, N gamma, and these reduced values of NC, NQ, N gamma we will be representing as NC dash, NQ dash and N gamma dash. Okay. So, you see, for local shear failure, thus the equation will be just changing and taking this form. So, it will be becoming 2/3 CNC dash plus Q NQ minus 1 plus 0.5 gamma B N gamma, gamma B N gamma dash. And if you notice this slide as well as this code also, see the local shear failure Q dash will be 2/3 C. It's not very clear, you can see from this code, you see it will be 2/3 C, it is 2/3, okay, it is 2/3 C NC dash plus Q NQ dash minus 1 plus half B gamma N gamma dash, and that's what we are exactly getting over here also. So, you can understand now. So, actually it is coming from Terzaghis bearing capacity equation only, and directly the code is giving net ultimate bearing capacity. That's why you see this equation in a little bit different form, but ideally the equation is same as Terzaghi has given. And you must remember the values of this NC, NC dash, NQ, NQ dash, N gamma dash, this needs to be taken, this needs to be considered from the table number 1. So, you cannot use it from the Terzaghi's value. Instead, what you will have to do, you will have to use the value as it is given in table number 1. So, let us see where is table number 1, page number 8 it is given, I think, page number 8, where are the values? Yes, this is. So, you see this is your table number 1. So, from this table number 1 you will have to get the values of NC, NQ and N gamma. And here you notice, in this case you see Indian Standard Code is giving the values jumping by 5 degrees.
Sir.
Yes.
सर सूरज का ज्वाइन नहीं हो रहा है.
सूरज. Okay.
हाँ,
सूरज
तो
is
उसका भी
there.
डिस्कनेक्ट.
Okay.
या सर उसका डिस्कनेक्ट हो गया.
Admit. Okay. Okay. Admit. Admit किया. Suraj is in
Okay.
now. Okay.
Yes, sir.
Yeah.
Thank you, sir.
Okay. Okay. So see, कहाँ था? Whereas in this. Yes. So you see the bearing capacity factor values. See the Terzaghi's bearing capacity factors and these bearing capacity factors may differ little bit. Okay. So whenever you will be asked to find out the values using Indian Standard Code, then you should use this bearing capacity factors. Okay. So you should use table 1 in the PPT. See, I have mentioned, see page number 8. So in the page number 8 table 1 this is being mentioned. Okay. And you observe here the values are jumping by 10 degrees. Not every 1 degree the values are given. Have you observed? It is given as 0, 5, 10, 20, 10, 15, 20 like that. Okay. So in between any values if you get, so if you have angle of internal friction, let's say as 39 degree, then how do you find out the value of NC, NQ, N gamma? I have earlier explained you through interpolation how you should be able to get the values of NC, NQ and N gamma. You remember? So you remember how to get the values for let's say if 30 degree value is given, 35 degree value is given. So if you want to find out for 32 degree, how do you find it out? Through interpolation. Okay. So, interpolation, through interpolation, how to find out the NC, NQ, N gamma value I have explained you earlier. Unless and until you solve a problem by your own hand, you will not be able to understand. Okay. So, interpolating between 30 and 35, you should find out what is the intermediate value. So, linear interpolation needs to be done between 30 and 35 to find out what will be the value of NC, NQ, N gamma at 32 degree. Okay. Now you see in this table only, if you notice, a note is given. This is very important. Okay. And this tells about the local shear failure and general shear failure. I think little bit larger if I do, you will be no. Yes. So, you can see here, for obtaining values of NC dash, you please notice here, NC dash, NQ dash, N gamma dash, what are these? NC dash, NQ dash, N gamma dash, what are these? These are nothing but the bearing capacity factor values for local shear failure. And once you want to find out for the local shear failure, what you will have to do? You will have to find out the value of phi dash, and this phi dash is nothing but this phi dash is nothing but tan inverse of 0.67 tan phi. What is 0.67? 0.67 is nothing but 2 by 3 tan
2
phi,
by 3.
right? So, 2 by 3 tan phi, and that is what we have said, right? So, Indian Standard Code, exactly whatever we have discussed till now, that is being followed in Indian Standard Code. Okay. So, once you see a local shear failure problem, in that case what you do, you decrease the value of phi by this formula. That means you find out what is the value of phi dash, and for that value of phi dash, that modified value of phi dash, you find out what is the value of NC, NQ, N gamma from this table 1. Is this clear? Is this clear to everyone? And you please notice in this formula, whatever is given above, what is being said. See 5.1.1, it is being said, the following formula shall be used for calculating ultimate net bearing capacity in the case of which footing? Strip footing. And that's what is Terzaghi, that's what Terzaghi also had said, right? So, this is for strip footing. You see this value, whatever you are getting, this is actually for strip footing, and this is for general shear failure, and this one, the above one, is for local shear failure. So, you see with this value of net ultimate bearing capacity, with these values of net ultimate bearing capacity, you could find out the value for strip footing only. So, if you want to do it for circular footing, rectangular footing, square footing, okay, then exactly in the similar way as Terzaghi has taken into the effect of shape factor and other factors, Indian Standard Code also specifies the values, how to take care about those shape factor, shape of footing, water table of footing, other things. Okay. Now, as we have discussed about eccentricity today, I will conclude this class showing you the effect of eccentricity. You see in the Standard Code, it is being said, what is being said, effect of eccentricity. You see single eccentricity, if the load has an eccentricity E with respect to the centroid of the foundation in only one direction. See, eccentricity can be in only one direction or it can be in both the direction. Okay. So, one directional eccentricity if you have, then the dimension of the footing in the direction of eccentricity shall be reduced by a length equal to twice E, and that is what we have discussed today. So, if the eccentricity is E, then the effective length or effective breadth needs to be reduced by an amount twice of that. The modified dimension shall be used in the bearing capacity equation and in determining the effective area of the footing in resisting the load. That is what his code is also saying, right? We have discussed it. And when there is a case of double eccentricity, we have also understood this. So, when there is a double eccentricity, in the length direction it is EL and in the breadth direction it is EB, then you see L dash will become L minus twice EL, and B dash equal to B minus twice EB, and the effective area needs to be considered as L dash into B dash. Okay. So so with this conceptual understanding, I think let us stop today, and in the next class we will discuss more about net ultimate bearing capacity and how to take care about other factors in the bearing capacity equation for Indian Standard Code IS 6403. Okay. So how the Indian Standard Code 6403 has taken care about the other things like the shape of the footing, depth of the footing, then inclination of the load, then water table, those factors, how the Indian Standard Code has taken into consideration in its formula, that we need to see and we need to understand clearly, and we will be discussing it in our tomorrow's or the next classes. Okay. Okay. So if you have any question, please ask. If you have any doubt, any question. Any question? No. No question.
Okay.
No. Let me take the attendance. Okay. Just a minute. Google Meet attendance collector. 28. Only 28 present. 30. Suraj and Imaj, what are your roll numbers? Maybe you have left, that's why it is not showing. Suraj and Imaj? Huh?
48.
48. 48, okay, I'll take care. Suraj and Imaj, I'll see. Okay. 08, Imaj Ali. Okay. 48, yes, that's good. Okay. So just a minute, I'll just take this print and then we'll stop. Okay. So okay, thank you. Tomorrow we'll discuss more about this thing. Okay.
Thank you, sir.
Thank you,
Okay.
sir.
Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.